Dilution calculations. When diluting solutions, some moles of one solution are used to make another. So you can think of having one container with some solution inside, and you have another container. You want to make a solution from the first container. So you're going to take some amount of the solution and scoop it up somehow, suck it up, and put it into this container. And you'll have some amount of it there. At that point, it's the same solution, so they'll be the same concentration. But then you will dilute that amount that you put in there by adding in some water, topping it up, and you will now have a new solution with a more dilute concentration. So this is always taking a previously existing solution of some concentration and diluting it down to a less concentrated new solution. To calculate the moles needed, how much you need to actually move over, so the number of moles needed to do whatever solution is you're trying to make, we're going to have to do some mathematical work to calculate how much is needed. Then we'll know what that number is, and we'll convert, make sure that it is in units of volume, so that we can take it out of the original solution and use it to make that new solution. So, for example, let's say we wanted to make 100 milliliters of a 0.1 molar solution, and we already had a solution that was 0.5 mole. So imagine we have this one solution that there's a flask, and in it is some solution that is 0.5 moles per liter. Now we want to make a new solution in a different flask that is a fifth as concentrated. So we're going to have to find out, okay, well, how much of this do I need to move over to here? And we have an ending amount that we want. We all want to end up with 100 mils. Now obviously if we just moved over 100 mils, it would be the same concentration. So we're going to move over a certain portion of it, and then we're going to top it up to wherever the 100 mils is on our measuring device, often a volumetric flask. But let's say the 100 mils there, we'll top it up with H2O up to that point. So we need to find out what is the amount that needs to be transferred over to make this new solution. If we know how many moles we want in our new solution, we can use that to find out how many moles we have to take out of our original solution. So that's the first part of the calculation. We can say, okay, well, I want 100 mils of this new solution. I can convert that using a conversion factor, just so I'm dealing with liters because my concentration is in liters. And the concentration of my new solution that I want is 0.1 moles per liter. So to make 100 mils of a 0.1 mole per liter solution, I will need 0.01 moles of solute to be there. That's how much I need to get out. Now you can't go and count those particles, but what we can do is we can take them out of the container in something that can measure volume. So if we can take our moles needed and convert it into a volume, what volume would have that many moles in it, we can easily measure that and move that amount over. So knowing that this original solution has a concentration of 0.5, we just need to find out, well, how much of it would it take to have 0.01 moles in it to transfer over. So the second calculation is, let's say we need this 0.01 moles to come out of the original solution. How much of that original solution has to be moved over? So if we take our 0.1 and we say, okay, that's the amount I want, I'm going to use the concentration of that original solution. How much in milliliters would it take to get the amount of moles that I want? So I'm taking my 0.1 moles and I'm converting it essentially to a volume of that original solution. Moles is going to cancel out. I'll be in liters, so let's do another conversion factor just to get to milliliters. We'll look at. Liters will cancel out if I convert to milliliters, and that's the number I'm looking for. So in order to get the 0.1 moles out of my original solution, I'm going to need to take out 20 milliliters. And then I can put that into a new flask and top it up with water. A quicker way of doing this is with what we would call a dilution equation. It's the exact same work. We're essentially finding out how many moles we need. So we say, okay, C1 V1 equals C2 V2, where the 2 represents the new solution, 1 represents the old solution. So essentially what we're saying here is the same thing we did here. The amount of moles that we're going to need to make the new solution has to come from the old solution. Those two numbers are equal. So we can say, okay, well, we know that concentration times volume will give us the number of moles. And if the number of moles needed to make the new solution is coming from the old solution, the number of moles that go to the new solution will come from the old solution. C1 V1 equals C2 V2. We'll see how this works with an example here. C is going to be concentration, and with molar concentration, we always want that to be moles per liter. V is volume. It could be in milliliters, it could be in liters. It doesn't really matter as long as the units work out in the end. So we can play around with what units of volume we want, but stick to moles per liter for concentration. 1 denoting the first solution, the original one we're starting with, or initial solution, and 2 is going to be the new solution or the final solution. One note, so C is molar concentration. Another word for that is often used as molarity. So if you hear someone talking about the molarity of a solution, they're talking about the molar concentration of the solution. And it is going to be measured in moles per liter. Now, as chemists, we like to take shortcuts. We like to make less work for ourselves. So often, and confusingly sometimes, moles per liter is written as capital M. So if you had a 1.0 mole per liter solution, someone might refer to that as a 1.0 capital M. They are saying moles per liter, they're just not writing out moles per liter. So capital M as a unit means moles per liter. As a variable in the equation, we've used as molar mass before, two completely different things. As a unit, it is the short form for moles per liter. Alright, so example 1. Let's say we wanted to make a solution, and here it is here. We want to make 100 mils of a 0.1 molar solution. What volume, and we'll put it in milliliters, of a 0.5 molar solution, and there it is there, molars, moles per liter, capital M, all the same thing, so 0.500 moles per liter, solution of hydrochloric acid would it take to make 100 mils of a 0.1 solution? So we've got a beaker, whatever flask of hydrochloric acid, and it's sitting at 0.500 moles per liter, and maybe that's too concentrated, and we want to drop it down to a less concentrated 0.100 moles per liter, and we specifically want 100 mils of this final solution. That's what we're going to use. So the question is, how much do we have to move over? And you may recognize this question. So let's try it using the dilution equation. So the concentration of our new solution we'll make is 0.1 moles per liter. The volume is 100 mils. We can put that in liters in our head. That's 0.100 liters. If you want to use the conversion factor to get that, go ahead and do so. The concentration of the solution we're using, I've written over here, but that is the original 0.5 molar solution. So, to find our terms, we can take our equation. We're looking for the volume of that initial solution needed to move over to make the new solution. So, we can take our original equation and use your powers of equation rearranging, algebra, to rearrange it to solve for V1. This is where you're glad you didn't use a triangle to solve your previously 3 variable equations, because then when you get to a 4 variable equation, that sort of stuff doesn't work. But since you didn't use that, you have the skills to easily rearrange, and you get V1 equals C2 V2 over C1. Plug in your numbers. So our 0.1 moles per liter as our final concentration, our 100 milliliters as our final volume, our C1 initial concentration of 0.5. Now, look what's going to happen with the units here. Capital M, moles per liter, and moles per liter cancel out. So our answer is going to be in milliliters. And we get 20 milliliters, just as we did before. Now realize, when you move 20 milliliters over into the new beaker, volumetric flask, whatever you're making it in, it is not going to be any different. It is not until you then add water to it, then you will get your concentration that you're going for, that 0.1 moles per liter that we're going for. So if we're trying to make 100 mils, and we've put in 20 mils already, we would then have to add in 80 mils of water to top it up. That's the dilution part. Example 2. We have a 50 milliliters, 50 mils of a 2.50 mole per liter solution of sodium chloride is diluted to 1 liter. What will the concentration be? So in this case, we're solving for concentration. Again, you can very quickly use the dilution equation, C1V1 equals C2V2. Define your terms, plug them in, and solve. And you're going to end up with a new concentration, taking the initial concentration, the initial volume, and dividing by the final volume. In this case, I've left it in liters. Liters cancels out, and I end up with my answer in moles per liter, which I have chosen to written as capital M. So the new solution will have a concentration of 0.125 moles per liter.